Okay. Yeah, come on in. Yeah, come on in. So, okay, let me make sure, just a couple of bookkeeping item. Um, Everyone can see the YouTube video, right? It's online and then no technical issue, one on. Good, okay. And then everyone can see the GitHub, right? Okay, good. All right. Okay, so one thing, so I've been reading the feedback from the forum, which is really great. If you miss it, it's no problem at all. It's kind of my fault because I forgot to mention last time. And then end of day today, obviously I'll mention it again just as a reminder. So yeah, so the forum in the end of the session, I really read those feedback carefully, and obviously I take it as a gospel, which is very important because it kind of gives me an idea of where you guys need help with, and then that's why we're here. And this is funny, like I've been teaching this class for like probably 8 something years. I've never seen this happen, right? Someone actually write an email saying they want more homework. I've never seen that happen. Like I've been teaching this class for a long time. I've never seen that happen. So I look at the problem a little bit, and I thought maybe this is a disconnect, and that's kind of partially on me as well, right? Um, I was kind of under the impression that there's a prerequisite for this class. Maybe I'm wrong. Like for example, you have to take data science, you have to take like some of basic class, like maybe Python basic, something like that. And then you do your project. That's what I'm under the impression of. I think maybe someone's taking this class out of order. So like I get emails like what is Python? Never used Python before. What is linear regression? Never learned linear regression before. And I think there's someone's taking this class like for the first time, which is totally fine. It's no big deal at all. But I also can't stop the class completely to reteach linear regression. You know what I'm saying? Like I can't stop the class completely to teach like Python 101. But I can do more Python if that's what if you know if that helps, and I can kind of dive deeper into she's she's shaking her head. But I can kind of like dive a little bit more into details if that helps. But just want to set a scene like I'm not planning on giving homework, just period. But if you want to do more, please feel free to email me. I mean, I can just give you more things to do. And obviously, I'm happy to read your homework, and I'm happy to provide feedback if that's what you need. But by all means, like we're not here to making fun of everyone. Just want to set a scene, right? There's a basic understanding that there are some classes that you took before this class, and if you somehow miss those classes, then that's totally okay. It's no problem at all. Like we're not kicking you out of class, right? Just email me what you need, and then I can probably put together a list for you, just depending on like where you're missing, right? It's no big deal. Because it is kind of like a wide group of background. Like there's someone mentioning transformers, right? Obviously not everyone here know about transformers, that sort of thing. So yeah, so that's why we're here. And then my overall goal is to use this class to basically give you guys all sorts of tools, as wide of a variety as I can, so that you guys can do something and then write something nice on your resume, and then maybe hopefully find a job. That's kind of like overall where my goal is. And that's not made up by me on the spot. That's like me reading the survey from last semester of where the challenges are. Some students, I think most of the students say the homework they're doing from other classes may or may not be helpful to help them land that interview or land that first job offer. And it's totally understandable, right? Because not all professors do projects, right? Not all professors do this. And then that's kind of like the gap that we're trying to fill here. And then there's also the nature of like how the class is set up, right? Because I have a day job and I work in the industry more than other professors, right? That's just nature of how the school set up different classes. Like there's some professors, they come straight out PhD program. There's some classes they have a day job and then they come here to teach in the evening. And I'm happen to be one of those professors. So obviously, my class is going to focus on more applied stuff. It's not anybody's fault. It's just nature of how the school set up different classes. right? And then hopefully they can cover a little bit of everything. So that's that. And then homework is kind of like what I consider more theoretical. Like if you can solve like in linear regression, like typically people have you set up some sort of formula and then solve for mean square error or solve for whatever, like the optimal solution, whatever. So if you can do that, that's great. That's totally fine. I'm happy to show you more of that if that's what you're looking for. Because if you write a paper, then obviously you need to know how to find mean square error, optimal solutions, things like that. Okay, so yeah, that's it. Just keep up the communication, right? If you need anything, just let me know, and then I'll figure out a way to help you. Yeah, yeah, come on in. Yeah, no worries. All right, any questions? Okay, so for last time, there's no homework in this class. But if you want anything, please let me know. Um, okay, Colab is Google's version of a Jupyter Notebook. It's basically an IDE for you to run Python code. And obviously, you're not required to do it. The only reason I do it is just because this is a classroom setting. And when I run something, hopefully you guys can run the same code and get the same result. That's literally the only benefit. Now, of course, if you can, if you want to go to VS Code, if you want to go to other fancy IDE with AI engine like Windsurf, Cursor, whatever fancy thing you can come up with, totally cool. Like, I'm not stopping you from doing that. But you do have to manage your own environment if that's the case, right? Like if I install Gradio 3.4 and then you install Gradio 3.3 and I have Gradio slider and then you don't, then that's kind of like on you to figure that out, right? That's the only difference. Other than that, not so much of difference. You can use whatever Python IDE that you want. Make sense? Any questions? Okay. The way I find Colab is literally I just Google it. Colab. That's the link right there. I think someone sent me an email saying they can't find it. Well, that's how you find it. You Google it. Or you can go to your Gmail and then just use the button. Yeah, create a file. Okay, so that's that. I think that's pretty much it. And then on top of that, there's Hugging Face, right? We'll talk more about that. Okay, so that's that. Let me talk a little bit about the overall vision. I think someone asked a question before. Overall, where the whole domain is going, it's obviously robotics, right? If you guys learning this class, like let's say 3 years ago or 5 years ago, I would probably say chatbot or agent or agentic AI. In terms of what we do today in the industry, that probably no longer is the hot spot right now. The hot spot is going to be robotics, like this kind of stuff. That's going to be the next main topic, which means there's going to be a huge wave of software engineer rushing to this domain and figure out a way to build software so that humans can interact with the robots much better and much more easier, whatever that framework is. And you can already see this happen pretty much everywhere in the industry. In finance, which is where I work, that domain is unfortunately a little bit distant from this because most of financial companies use software. They still use software. Like you're not gonna see a bank have like a robot running around, right? That's maybe a little bit too far away in the future. But the most immediate space for this to use is assembly line. Like assembly line, like in a car manufacturer, like assembly line. Like this kind of stuff. That's gonna be immediately where the use is happening, and for obvious reasons, right? Like, if this thing shuts and then your arm's there, then you lose your arm. Then next thing you know, it's like millions of dollars of lawsuit, right? And you have to go to the hospital. So obviously, instead of having a human doing stuff here, then the next thing to do is these machines gonna have like robot arms, and then they're gonna do things in your car, or whatever it is, playing engines. You get the idea. So that's probably the immediate way. And Amazon's already doing that. So Amazon factory robots, Amazon's already doing that. So they basically right now these machines, these boxes have your stuff in there are all moved around by this kind of like they kind of like a Roomba. Anyone know what a Roomba is? It's kind of like the vacuum thing that goes in your house, right? Exactly, like it's the vacuum thing that goes in your house that clean your floor. So it's literally the same idea. There's a camera here, and the camera is going to see what's in front of it. And then there are all these labels. This picture is probably not that clear. But there's some pictures that lay that out. Like there are all these drawings on the floor, and they're color sensitive. So it just makes the camera easier to recognize, hey, that's a target, and then that's where you put things, or that's where you pick things up. Logic like that can pretty much be built and guardrailed. And then that's how Amazon's able to like have the 2-hour delivery window. It's completely 100% based on this. Humans is not able to deliver within 2 hours. That's never gonna happen.
We want that roaming around the streets these days. I see them a lot, robots. Yeah, I mean, they're like delivering some sort of items to the households.
Yeah. I don't know. Are you talking about the robot dog? What is it from? It's Boston Dynamic or something. Are you talking about this?
The Uber Eats robots. Yeah.
Uber Eats robot. I've actually never seen that before.
Yes, this little.
Oh, cool. Okay, I have seen this before. I didn't know it's from Uber Eats. Are they? I know the concept is there, but I don't know if it's operational. Is it operational?
Yeah.
Oh, really? Okay.
The light is red.
Oh, okay.
They wait for it to go green. And it delivers the food.
Oh, okay, pretty cool. I'm assuming there's some sort of like insulation there so that your food doesn't go cold, right? Yeah. Okay. Pretty cool. Yeah, so yeah, I'll look into this more. I actually don't know about this. I mean, I know the concept, but I didn't know it's operational. So pretty cool. I mean, this picture actually says it's in Jersey City. I'll probably take a train to see it over there. Yeah, pretty cool. So yeah, anyhow, the stuff is out there, right? It's not like we're not talking about Star Wars or some futuristic thing. Like it's right now, right? It's happening right now. It's just a matter of are you involved or not, right? It's like the stuff is happening right now. And the way to be involved with this kind of stuff is you go back to the problem statement, right? You go back to the model and you think about what's on these robots and what's the data input and what needs to happen from data input to decision-making process, right? So that's how you think about these problems, which is why I think I mentioned this last semester as well, which is why you have to go back to this paper. This guy, Yin Kun, I mentioned his name last semester as well. I like him a lot because when I was in grad school, obviously I read a lot of his papers. That's kind of like a standard way to get you started on deep learning. And then he has a big bet here on this paper called iJEPA. I think there's another version in 2024 called vJEPA. The idea is actually very simple. The idea is basically saying there's some sort of a model here. This is the archive paper. This is pretty much the idea. And I tell everyone the idea is here. It's a generalized idea. So you're not able to just look at this picture and be like, oh, I have a model, right? It doesn't work that way. This is a kind of like an abstract, generalized idea. Basically, it's telling a very simple story. It's saying there's some sort of input, there's some sort of output, and then the input need to be encoded, and then this input can go into some sort of model, and the output can go into some sort of model, and you compute the loss. And the D you can kind of think about it as some sort of loss function, some sort of difference function. That's kind of it. That's kind of like the idea. And then somewhere down the road, he's introducing Z. Z is like a latent layer. It's learned by machine. It's not data, right? It's completely learned by machine. And then this Z, you can kind of think about it as an auxiliary layer. If you don't understand what I'm talking about, then there's a paper called, there's a model called Siamese network. I should probably Google it. Oh, you don't have to Google, it's this one. So there's one paper that's very important that introduces a concept called Siamese network. How it works is you can introduce two input, and then you can compute some sort of loss in the end. That's pretty much what the paper is talking about. It's a new design that says, hey, this layer, this neural network layer, it's so flexible. And what do I mean by flexible? Well, you can pretty much like consume anything. That's what they're trying to say. So it's a small leap from this kind of stuff to what Yan LeCun is trying to say here. And what he's trying to build up here is it's an abstracted idea that pretty much leads to how you that pretty much leads to how you solve this kind of problem. So now that's easier said than done. But how it works is you have to think about the machine put in front of you. What does the data structure look like? So if you think about in the industry level, some of you might not be able to. Some of you haven't worked in the industry before. That's totally fine. That's why I'm here, right? I'm helping you fill in the gap. So to do this kind of stuff, you need to have these robots out there to collect data first. That's like step number one. If you can't put in real street, then you put in your lab, right? In your lab, this robot's going around places trying to collect data. And then how it works is you have a camera, and then the camera basically is recording a bunch of videos. That's like step number one. So immediately the data engineer or the AI engineer is going to be given like a folder with tons of videos. That's going to be step number one. And then videos, if you think about it, it's basically a sequence of image, right? So sequence image, it's going to be 1, 2, 3, 4. It's going to be at least 4-dimensional. If you plus the time, it's going to be 5-dimensional. So you can think about something like this. What's a good picture? This is probably a good idea. Okay, so the picture has pixels. Yeah, pixels is basically these grayscale numbers that represent how bright each spot is. And then a picture consists of rows and columns of different numbers, different grayscale pixels. And in this case, if it's a black and white, then there's no color. Black and white just means there's some spot you can see, there's some spot you cannot see. And the spot that you can see is just a white spot. So it's like the stuff in the middle. That's the pixel that you can see. There's some spots that you cannot see, like these guys on the edge. These are the values that are so small that you cannot see. And human eyes process this figure as a number. Why is that the case? Well, it's because human roll the numbers like that. And that knowledge comes purely 100% from human. It's not like some machine make this up. It's just human write numbers this way, and that's plain and simple. It's just because human it's habit from long ago. So this on the surface is 2-dimensional, right? Rows and columns, 2-dimensional. Now, if you add color, then what that basically means is you have a grayscale, but you have a grayscale for RGB, red, green, blue. So you have this picture, but you have 3 slices to create the color. The most basic thing I can probably think of is there's a class called Stanford CCS 224, I believe. No, I lied. Stanford CN class. 231. Okay. And then there's is there like I forgot which slide it is, but one of these slides they have a picture. I should probably save that link. Can't find it for now. RGB image. It's basically the 3-scene color, and then the grayscale will pick the grayscale is applied on every channel, and then altogether you form the color. That's kind of it. That's that's basically what I'm trying to drive at. So once you have that idea, then you can kind of like come back to this and think about, okay, that's one picture, and then how do you make into video? Well, a video is just a sequence of these pictures altogether. If you run some basic numbers, you can kind of think of something like this. Let me go to Google. So you can think about something like, let's say you have a video that's 100 frames. So 100. And then let's say the video is like high resolution, like 4K camera, like extremely clear. So you can kind of think about that as yeah, something like this. I'll just make my math easier, like 2048 times. You know what? Let's not guess this. 4K camera resolution in terms of number of pixels. That's pretty much how many pixels there are for for 4K camera to capture, and that's one picture. Just FYI, that's one picture. So whatever this number is, you know what? I'll just say 8 million, right? Let's make a number easier. So 8 million. 1, 2, 3, 4, yeah, 8 million. And then you have color, right? So it's like RGB. So it's like 3 color. So that's how many pixel, that's how many numbers are there in that data set. If you just have like 100 frames, right? Now you have to think about how, like, why is 100? So this is thing called film per second. So how many film or frame, sorry, frame per second um, can today's camera see? It's not a small number, it's a big number. So live video is probably 30, and then action sports version is probably 60. Like you can go to your iPhone and just turn the video on. There's like an option on top right corner saying like 30, 60. That's what this means. Right. So this is FPS, right? FPS is frame per second, FPS, right? Frame per second. So 1 second, it will basically take 30 pictures. And then when you play the video, it's just displaying the pictures one by one. So let's say someone give you like let's say you know what, let's say a minute of video, right? So 60 times 60, so that's 3600. And then so now what that means is this is not going to be 100, this is going to be 36. Oop. Right. So that's how many numbers you're handling in a 1 minute video. And we're not even talking about a long video, it's just a 1 minute video. Does that make sense? So that's the data input, right? And then you can immediately kind of like simulate how slow this gets. I can show you guys this real fast. It's gonna be really slow. So you can do something like this. I can probably close this. Where's my Python? Okay, so let's see. I'm gonna use AI for this because I'm just so lazy. I give me a Python code using NumPy to generate a random matrix that is shape of this. And I want you to I want you to generate this 100 times and time it. So do this in a for loop and then time the difference. Oops. And then you can probably time it, and then you get the idea how slow it is. That's why I'm not doing it on my own computer. That's why I'm doing it on Colab. Where's the code? Oh, I already did it for me? Wait, no, that can't be it. Give me a Python code to do this. Oh, there you go. Got it. Okay. And then you can go to your Colab and use the running. Is it going to print out stuff? Yeah, okay. So there you go, you get the idea. And altogether you can time this. And this is just 1 minute, right? Like someone give you like an hour video, then you're like, oh crap, like this, like you got time that by like 60. And if someone give you 2 hour video, then it's like scale up. Typically in industry, like for example, like the job before my last job I work at, someone give me a video that's like someone set up like a data pipeline that's generating like gigabytes of video in a day. And that's how big of a data feed that a camera can produce these days. And that's like 3 years ago. So you're gonna really have to think about like you really have to think about when you're building this model, like especially this X encoder here, when you're building that, how fast can you do? And then how much GPU do you have to have to pull that off? So that's the compute part. And then in terms of inference, you also have to do the math of, hey, this is how large the picture is. How fast can the GPU run the compute? Because think about it, you can't have, where's the robot? Like you can't have this to take like a minute to open a cab so you can take the food out, and take another minute to close it, right? Like it needs to be like happening really fast. So those are things to think about when you're handling a project like this. And then all that said, like once you figure that out, and then you can then think about, okay, what model to build. Does that make sense? Any questions? Okay. So why am I telling you guys this? I think this kind of give you guys a vision of what can happen, if not already happening. So that's one idea. Another thing is probably today the biggest one is MetaQuest. Um, I would probably say if you're handling, if you want to do computer vision, the most advanced computer vision that you can probably do is something that goes into the MetaQuest. They still have the industry standard, like they hold up the industry standard of what the today's AR VR can be if video is what you're interested in. Like you have to think about this in the opposite way, right? If someone says, I'm interested in video, and then they don't even know what's going on here, then how are you going to convince people that you're interested in video? It makes no sense. So if you're interested in video, then eventually you're going to have to start thinking about something like this. And the way to pull this off is one crucial thing is depth perception. That's something very difficult to pull off because everything else we got it, right? The color we got it, the speed we got it, the neural network model we got it, like everything else we got it. The difficult part about this project is the hand-eye coordination and the depth perception. Like when you see something in the AR glasses, it's like the difficult part is how deep that picture is in terms of how it's presented in your glass versus how human eyes perceive the picture in the real world. And that's something very difficult to do. And then on top of that, you have a controller using like some sort of like a remote controller. If that's what you're interested in, right? So we're working backwards. So you figure out what you're interested in, you figure out what the problem is, and then you work your way back to figure out what the model should be, right? So the model that you should be worried about is something like a depth model. What do you call it? Depth model, Hugging Face. Depth anything is a good one. Let me see if I can get this kind of stuff. Yeah. How do you train this? So how do you train this? Well, it's very simple, right? It's image to image. So you take a original, maybe I should just go into this. It's a repo, right? Correct. Yeah, it is augmented. Yeah. I'll probably zoom in like something like this. So how do you train this? So your training data need to be like this. First of all, you have your original picture, right? First of all, you have your original picture. This is nothing. You just take your camera and take a picture, right? So this is easy. The difficult part is how do you create the training data that look like this? So that's the difficult part. Now, of course, you can find a model that already exists. That's probably the easiest way. But then how does that model exist, right? Like there had to be like the first guy that eat the crab, right? So the first paper come out, which is you look at this picture, that's the original picture, and then you basically calculate like the engineers have to come in and you calculate the focus point of where the camera is, and then you use that as a tool to calculate the pixel to the focus point to reverse engineer the color. So the one that's closer to the focus point, you mark as one color, and then the one that's further away, you mark as a different color. And then you can kind of think about this as one of those color map on Matplotlib library in Python that high value is like yellow and then low value is like purple or something. It's like one spectrum, even though this is like multiple colors. Does that make sense? And once you have that, then you just generate this like a million pictures. And once you generate a million pictures, you can then train a neural network model that's image going in and image coming out. And then that image coming out, once that model is trained with a small error, you can then send in a picture and then the model will be able to produce this guy here. And then the best way to do that is probably UNet. UNet for depth depth estimation. I think there's a paper about that. Like that's a good one. Something like this. So it's an image in, image out model. So what that means is it's a neural network model. Image goes in, and then there's image coming out. So it's generating a picture. The only difference is the training data is this pair. So training data has to have this pair. Otherwise, like how do you expect model to learn that, right? So once you have that, train the model, get the error down, and then you have this model. The weights is in these layers, and then you just save the weights. And once you save the weights, you take a new picture, send it in here, and then guess what? It will produce a new depth perception. And that depth perception can then be engineered into where's the thing? And then the depth perception can then be engineered into these into the creation of these pictures. Make sense? Any questions? Okay. So that's another field if you're interested in. It gets very niche very fast. It just kind of like depending on like truly what you're interested in. The overall in the industry, what I found very helpful to think about is you start with the problem statement. You start, let me take a step back. You start with what you're interested in, like what truly motivates you, like what truly makes you interested, like what wakes you up in bed in the morning, right? You start from there, and then you look at the pain spot of what people are doing right now and why is it that they're failing. And then you ask yourself, okay, this is why they're failing, and then this is how I can solve the problem with the tools I know. Does that make sense? So typically that's how you do it. And then if you're able to figure out that cycle for yourself, then the next thing it's gonna get like easier and easier to go about things from that point. Once you figure out what a cycle looks like for yourself, and trust me, everybody's different, right? That's why I hate exams, because exams assumes everybody's cycle is the same. And that's, taking my words for it, everybody has their own cycle. That has to be the way, because everybody think about problem differently. So everyone has their own cycle, and unfortunately, exams can't find that cycle for you, right? And and another person also cannot find a cycle for you unless you literally spending 24/7 with the person and they know everything that you do. Then maybe that person can guess what cycle, which stage of a cycle you're in at the point. Maybe if they know you very, very, very well. But at today's day and age, everybody's reading different news all the time. So it's going to be very challenging for someone just magically guess, oh yeah, you're in the beginning of a learning curve. Like, it's very difficult to say that. It's also very difficult to say, oh yeah, you know everything you know. That's also very difficult to say that. So unfortunately, the best way to figure out where that cycle is going to be yourself. Make sense? And me as a professor or as an instructor is like I hope I can like encourage you guys or nudge you guys to find where that cycle is for yourself to the best of your ability. And obviously along the way, I shove you different tools. Here's a tool that does X. Here's a tool that does Y. There's no tool that does all the like. There's no tool that does everything. But maybe there's a tool that does a little bit of here and there. And then maybe throughout the way, you can kind of pick up those tools, and then you can solve the problem that you're really interested in. Does that make sense? Cool. Any questions? Yeah. Okay, awesome. So that's kind of like a long answer for like my recommendation of how you think about problem overall and how you think about this class. And then yeah, so before I jump into today's content, what I'm thinking about is let me go to the class repo. GitHub branch 2025 fall. Okay, now I can talk about this. Now this will probably make more sense. Okay. Most of this, if not all of this, it's kind of like there's maybe a little bit pictures in the Gradio, but most of these code here are assuming that you are building a solution for someone to use on computer, right? The leap of faith, and probably the only leap of faith, is the voice. That's probably the only leap of faith. Other than that, most of these solutions here are making the assumption that someone is doing something on their laptop, right? Like we're not talking about robots yet, right? But there are some tools in the Gradio to help you think about how to consume an image, how to generate image, that sort of thing. And then hopefully we can get there. But I think if you kind of like know most of, like let's say dream world, in the dream world scenario, you know everything in this repo. I would say that should be plenty of tools for you to pretty much handle a project completely by yourself. And then also it should at least get you like that. If you're looking for a job, it should at least get you that first interview to talk about things. And then hopefully, the content in this class and then throughout your experience of building one of these projects can allow you to talk about a couple of important things. There's only a few important things that you have to know about these projects. And then, throughout the class, I'm gonna basically like re-mention them again and again and again so everyone know. So first thing is you have to like try to force yourself to be a full stack developer. What does that mean? What that means is you do the front end and you do the back end all by yourself. And then that's kind of like on a high level. I can answer the same question in a technical way. Technical way is there's some script that creates an API. There's some scripts that calls the API. That's a technical answer. But basically what that means is you build the backend, you build the front end all by yourself. That's it. Some students come to me saying they've never used React, they've never used Node.js. That doesn't matter. Large language model can write that code for you. But you just need to understand the logic. And hopefully I can use this class to help you understand the logic. So that's one thing, a full stack developer. The next thing that you have to know is containerize things. I don't think I have anything here, but I can probably say a little bit. Containerize the code basically means Docker container. So I'm talking about this kind of stuff. Docker container. So I'm talking about where's the fish? Yeah, this it's not a fish, it's a whale. So it's so whenever you see this whale thing and then they're like boxes on top, like that's Docker container. Docker container, it's an easier way to basically manage your package, like a software package or web app or mobile app or whatever. Because think about it, you don't want to like copy code 50 times from one directory to another directory, right? You just package everything into one file and then you just push that one file from A to B, right? So it's just a way of, it's basically a fancy way of saying, okay, here's a zip folder. I'm giving you a zip folder and has a bunch of scripts inside. That's basically what that means. So that's Docker. And then I think that's pretty much it. That will probably get you past 80, 90% of the interview if you know everything I just said, right? So I think hopefully throughout this semester I can kind of show you guys a little bit of what that means. We're not going to get to this today, but I actually have a class planned to talk about this in depth. And the way we do that is when you get to here. When you get to here, what's happening is there's a little tutorial for you to do something complete from scratch, which is you generate a PDF by yourself, complete from scratch. You scrape the PDF, get the text out of PDF, generate a question and answer pair, and then the question answer pair becomes training data, and then you can fine tune a llama model using the training data. Everything is lightweight. So we're talking about maybe a few lines of code, and you can just go through the experience of all of that. And then the repo that you do is this one. This is the repo that we go to. Don't worry about this for now. I mean, I have videos here. If you want to watch a video, feel free to watch it. But don't worry about it for now. It's gonna be a fun project. I promise you guys that. Some students did this before, and then typically it goes both directions. One direction is it becomes a paper, right? Very simple idea, right? You have some sort of PDF that you created. It could be I don't want to tell you guys to take your class notes to do this, but if you want to take your class notes from other classes to scrape it, do it at your own risk. I have students do this before. It depends on your scale. If you just take one note from one class, no one's going to bug you with it, right? But if you take your entire lecture slides of like 2-3 classes, then obviously other professors not going to be happy with it. Anyhow, point being, the skill is here. You can take a book, scrape it, and then train a model complete done by yourself, right? So that's the skills. I'm going to give you skills. Now, does that mean you can do it, right? That's a different question, right? Why is a different question? Because it requires high GPU, high computing power. So not everyone can afford that, right? But that's totally okay because I actually have credits for you guys. So what I'm going to do is, I think I have it here. Let me see if I have it here. Where is it? I might have forgot my password, but let's try it. That should be my password, right? Is that no? Sign in. Sorry, that's my fault. Sign in. Let me try signing, and then I'm going to explain what is it I'm trying to achieve. Okay, good. I remember my password. Okay, so let me dismiss this. Where's the sorry, let me find it. I remember there's a team access. Is it cluster or? Oh, there we go. Okay, so I have a connection with this company called Rungpod. What is Rungpod? Rungpod is a GPU renting company. So let me unpack that sentence a little bit. So wait, no, that's not one. Enterprise car rental. You guys seen this before, right? Enterprise, right? You you rent a car, you drive away, you have fun, you do whatever it is you do, and you return the car, right? So it's the exact same business model with GPUs, except for GPUs, you're not like you're not driving a GPU away, right? The GPU just stay on the cloud, but you gain an access of using those GPU for a certain period of time. Everyone follows? So in this case, you don't have to pay for the GPU full price. You just rent it for a certain amount of money for an hour. Usually it's very cheap. Like we're talking about like $1 per hour. And then you can throw your jobs on the GPU and basically do your thing. Make sense? So any questions about the model? So that's basically what they're doing. So they're the enterprise of GPU world. Okay, so that's the model. And that's what the company is doing. Okay, this website is the company's platform to allow people to do that. Okay, so that's that. And then I have to figure out like how am I going to add you guys? Ideally, everyone get a try. But I haven't figured out the limit per person sort of thing. I only have $400 limit here. What I don't want to happen is someone log on this, get like 20 GPUs all by themselves, and then exhaust $400 in like a minute. Like I obviously be respectful for your classmates, right? Like it's a share space. If you use for like $5, that's fine. But if there's like an hour that you use like 20, 30, $50, then obviously start like shut it down. Does that make sense? Ideally, I put some sort of limit on it, but I need to talk to them to figure out how to do that. I haven't figured out how to do that yet. But anyhow, the stuff is here. Hopefully, I can get you guys access to this. It's not required by any means. So it's not like I'm not assuming that you have to know this, right? This is above the scope of the class. I just want to provide you the opportunity if this is something you're interested in, right? So when you interview, you can say, yeah, I've fine-tuned a model before, and this is how you do it, step 1, 2, 3. So I want you guys to at least have the knowledge, right? Even if you don't do this, I'm still going to talk about this in class. So you still have the knowledge. It's just a matter of if you're going through the steps, obviously you know more about it. So that's really the difference. So stuff is here. There's a class in the future. We're gonna do this in like an entire 2-hour time frame, and we're gonna do this complete from scratch. So everybody's on the same page. Obviously, everything's recorded. I already recorded a bunch of stuff on YouTube about this kind of stuff. Yeah. So this anyhow, the stuff is here, and we're gonna talk about it, right? I'll give you guys a preview, and we can probably take a break. So the way you do it is let me start with the easy way first. So the easiest way is the pods. So there's pods and there's serverless. Let me talk about pods first. So these GPUs are all up for rent, all up for rent. Rent means they don't belong to you. You can rent it for like an hour or 2 hours, something like that, right? Now, there are different prices because GPU have different model sizes, right? So typically how I go about it is the first time you're like, oh, like what do I click on? This is a mess, right? What do I click on? Like that, like is that, right? It's gonna be uncomfortable. So this is how I would think about it. It depends on the model you're trying to build. Make sense? So I'll repeat that again. It depends on the model you're trying to build. If you just want to build a neural network model to classify cats versus dog, right? We're not talking about a fancy model. We're talking about maybe a neural network model with like 2 layers, right? If that's the case, just go with the cheap one. It will get you past the hurdle, no problem there, and it will pretty much beat all the CPUs out there. So you'll be fine. If you're gonna be doing something that's a little bit more fancier, right? Fancier means you're moving away from classification. You're going to generative AI. And then the model that you're training are creating a sentence, creating a picture, something like that. That's when you need to start thinking about a higher tier. Higher tier models are H200, B200. These are the latest version out there. Latest just means they're the most advanced one from NVIDIA. Obviously, the price are also more expensive. This number here is 3.79, like this number here. So this number means $3.79 per hour per GPU. So if you use this for 1 hour, you get charged $3.79. Make sense? And then on top of that, I think there's a storage fee, but storage fee is kind of like small. You can just delete it afterwards. I don't expect that to be a problem. Worst case scenario, you just download the file, right? It's not end of the world. So that's one way to think about it. You know the number, you just go with the number, right? Sorry, the name of the model, right? Okay. Now that being said, it's not always the case that you know the model. Like, how do you know you're gonna buy exactly the like Audi A4? Like why Audi A4? Like you don't know that, right? You don't know the exact model that you're gonna use like right in the beginning, right? Unless you know Audi, the car brand, and you know A4 is the car you want, then you go buy A4 immediately. But what if you don't know that, right? How you think about it is you filter by the RAM. And not just any RAM, this is the vision RAM. That's why it says VRAM, right? So VRAM is the size of the memory in the GPU that it can compute up to the maximum level. So any just means there's no filter. But typically how I think about it is if I train a model that's Llama 2 or Llama 3, pretty much anything here, it's fine. If you go to Llama 4, like we're talking about billions of parameters, like if you go to 30 billion parameter, I would say you are in this range. Make sense? If you're in 100 billion parameter, I would say you're probably in this range. Make sense? The range is not completely black and white. Why? Because it depends on how many data you're throwing. Like I could be training a model with 100 billion parameters, but if you have a data that's like 10 samples, then obviously you can like be like, okay, I'm gonna go down here. That's not a problem at all. But if you're gonna say, hey, I have a model that's like 1 billion parameter, but you have a billion samples, well, too bad. Then you're gonna have to go up here a little bit. Right? So it's not black and white cut. It just kind of depends on what you're doing. Make sense? Now, unfortunately, I can't give you guys more information than that because it just really depends on what you're doing. So if you need more knowledge in that arena, then come talk to me after class. I'm happy to talk to you more about it. And this kind of math, like we do this in the industry every day. Like I do this, I had to do this like literally last week. Like I had to work out the math with the VP of the company, and I have to tell him, I have to say, hey, look, this is the model you want me to train. This is the data sets that you have in the company. Therefore, this is a GPU you need to give me. Otherwise, if you don't give me this GPU, instead of a month delivery time, I can only deliver in 6 months. Then if you're happy with that, I'm happy to deliver in 6 months. But if you're not happy with that, you want this in a month, well, then we need this GPU. Make sense? So that's the argument that you're going to make when you're in the industry. And no one's going to figure that out for you. That responsibility falls on the data scientist. Make sense? Any questions? Okay. I think that's 7 p.m. That's good enough for an hour. Let's take a 15-minute break. Let's come back at 7:15. Okay, we can start the next session. So let me show you guys a little bit more on this. And then just at least how you guys get things started. Just so that we have this on recording. In case someone wanna pop in here and take a look. And then as I said earlier, for future reference, there's gonna be one class dedicated to how to do this for real with an actual large language model. But for now, typically this is how I would do it. First of all, understand what is it that you're trying to build, right? Because that determines the GPU instance, and then the GPU instance, once it's selected, you can then create a pod, right? So that's the logic. If you don't know what you're building, you don't know what GPU you should be using, then how are you gonna create an instance? So you won't know that. So for time being, since this is demo purpose, I'm gonna pick the cheapest one I can get. So what I'm gonna do is lower this to the cheapest one. I think this 40 cents probably the cheapest we can find. This one is 20 cents. You can use that as well. I'm gonna find this is probably the cheapest I can find. Once you click on that, what I did was I click on this. So once I click on this, it will take you down here. Actually, you know what? Let me go back up here. So let me say a few things about this. The secure cloud, you don't have to worry about this for the time being. This is only if you have a project that's like private for whatever security purpose, right? So for now, you don't have to worry about that. In terms of network volume, for the time being, you also don't have to worry about that. This is assuming that you have some sort of online drive that you want to save your data or save your model weights to that drive. Then you can plug that in. But for the time being, if you're just running a GPU and then you get out of there, then you don't have to worry about that. Region is this. So everyone know about data center, right? So data center is this giant factory that everyone is building right now. Wait, data center, it's this thing. And then it's basically a factory look like this. And then inside this factory, it's like these shelves of GPUs. And then why do you want to put it as the shelves? Because they want to control the temperature, and then they want to control the electricity and power infrastructure of those GPU. And then obviously these all have internet, right? So that's what data center look like. Like some people say data center is actually like more secure than White House. Like this is not a joke. Like to get in data center is actually more difficult to get in White House. Like it's easier for to go to White House than go to data center. So it's very it's very interesting. And then anyone know the size of the latest data center that Facebook is going to build or Meta's going to build? That's Manhattan. So this is my Manhattan Island, right? Like that's Midtown. Like we're probably down here, Brooklyn Bridge, and this purple area is the size of data center that they're trying to build, and that's one data center. And then why do they want to do this? Well, the reason they want to do this is because exactly what we just talked about before, right? It's because they want to do. It's because they want to do this. Make sense? And then you can kind of imagine the scale that it takes to do this, right? So we're talking about like buildings of shelves, and then inside of the shelves are all GPUs. So that's kind of like how massive the scale is. It's actually scary to think about. Like you could get lost in there for like days, and you can like starve to death. So it's funny. Like imagine you're walking. Wait, where to go? Data centers. Here, if the building is the size of Manhattan and you get lost in here and you don't know where to go, you just die in here. Like you just lay there and you're dead. Like, you can't get out of there. So that's just in terms of scale, that's how you think because it's basically a maze in there. Like if you have no way, like you have no way to exit the building, then you're kind of screwed. So that's how big the thing is. Anyhow, why am I talking about this? So that's what these regions are talking about. Every region has data center, and then if you want to go for a particular data center, you go for that region. Now, in terms of fine tuning, this probably does not matter for you. It might matter from time to time. Like for example, if let's say hypothetically speaking, Amazon has a data center in New Jersey. And for some reason, JP Morgan has like opened up like 20 more offices in New Jersey. Then I would probably say, okay, move away from, if you put your cursor here, like some of these is gonna start shutting down. Does that make sense? That's the only impact to what we're doing. Now, that being said, and again, probably you guys are not going to get affected in terms of this class, but just for your knowledge, right? If you are deploying something, let's say you have a model you want to get deployed, and then you want to have a GPU. These endpoints is going to put your model or the artifact of the model, that's a more accurate way of saying it, in that GPU, in that data center. And then that's going to be in a situation where if a data center is shutting down, and then that will affect your endpoint of the model that you're using. Because the endpoint is live. Why is live? Because your model is on that GPU, and the GPU is in that factory. If the factory get burned down in that data center, and let's say the data center is on the East Coast, and there's literally a fire there, then obviously the chatbot that you're building that's using that endpoint is going to get shut down. Make sense? So that's the logic. And if you do this in the industry, this happens all the time, right? So just so you guys know, but for the sake of this class, you're probably not gonna get affected if you're just using it for like an hour, right? Okay, so that's kind of like a long answer to what's going on here. So I'm gonna continue my story. So select GPU. Now you have to select how many number of GPU you want. So this is getting into distributed computing, or also known as parallel computing, right? So what's going on? In some scenario, the GPU will be even the most expensive GPU out there, it's not enough to help you finish that compute. That is going to be a scenario where you want to have multiple GPUs, right? So the way to work that out is you have multiple GPUs, and then the GPUs are sharing the weights and sharing the gradients from one to the other. So let me unpack that sentence a little bit. Let's say, grab a picture. What's a good picture? This is a good picture. This one. I want to zoom in a little bit. Can I zoom in? Okay. You actually don't have to see it. You just need to see there are like 4 boxes, and then that's pretty much enough. So you can forget this the zero. You just need to understand the logic. That's the most important thing. Okay. So let's say you have data coming. So data is this arrow, right? Go from left to right. Let's say that's the case. Originally, you are doing everything on one GPU. So how it works is, imagine you just have one of these boxes, just one. And then you have data coming in, and then it will take up the compute one by one by one by one by one until it runs out, until it takes up all the compute. So one of these boxes you can kind of like loosely think about as a compute source. Okay, if the data is small, you don't take up all these boxes. You take up like, I don't know, 10% of it or 20% of it. And then you finish the calculation and then you're done. So a neural network with like 1 layer or 2 layer, you can think about as maybe just take up 1% or 2% of the boxes. And then you'd be done with it. Now, the problem is, if you have a data coming here that's huge, like hundreds of billions of parameters of like Llama 4 or whatever, like something like that, then the data is huge. And as a matter of fact, data is so huge, it's probably going to be larger than this one box. Then that's going to be a problem, right? That's going to be a problem. So how it works is this diagram on the right-hand side. So what does this mean? So how it works is this. You have 4 GPUs, 1, 2, 3, 4, right? So this is a 4 GPU, 1, 2, 3, 4. And then you take the data, since it doesn't fit on this, right? It doesn't fit on this. So you take the data, and then you compute the weights, and then to a certain point, you stop. You don't even touch the 100% of it. To a certain point, you stop. And then what happens when you stop? You are in the middle of calculating the gradients. That's what that means. You have, let's say you have a neural network with 10 layers, right? You stop in the middle. So you haven't finished 10 layers of calculation. You only did like 1 layer or 2 layer. Like just have a visual comparison. Neural network. Just think about a picture like this, right? Let's say this is like not 3 layer, like 300 layers. Just think about like that. So you haven't finished all these layers. Maybe you've only done one. So that's what that means. So then what happens is you haven't finished. That's okay, right? So you offset the weight. So you take the weights off the GPU, you put it somewhere else. So that's called cache. So you put the weight somewhere else. And then you take the same gradients and then you go to the second GPU. So now guess what? Once you do that, the first GPU is now free. And then the second GPU is now doing the job.
The next GPU because previous one doesn't have space anymore.
It's because you're purposely not using all of it. Because you can't fit everything on it. Does that make sense? Yeah. And then you just keep doing this. And then once you're on a second GPU, you don't do 100% of it. You only do part of it, like a layer or 2 layers, something like that. And then once you at a stopping point, let's just say 1 layer for simplicity. Once you're at a stopping point, you offload the weight, put it somewhere else, save it, and then take the gradients to the next GPU. And then you just keep going. And then to a certain point, once it finishes, you can then come back to the first one. And then you just keep doing this rotation again and again and again.
Space in bits and pieces.
Exactly. Yeah, in bits and pieces. Yeah. Any questions? So the most intuitive way to think about this is actually very funny. Like for example, you have like let's say you have a problem set with like let's say 100 problems, right? Instead of one student solving the 100 problems all by himself, he basically can say, hey, wait a second, I'm gonna solve the first 10 problems, and I'm gonna give answer to you, and then you learn a little bit about my answer, and hopefully you can solve the next 10 problems. And then the second student is working on next 10 problems where he doesn't stop, right? He doesn't go do something else. Like he comes back to the next 10 problems and he keeps going. Does that kind of make sense? So that's how they get away with distributed computing. The benefit of this is you can fit in a data that's very large, right? A data here, it's not just the training data, it's also referring to the model. So this is a kind of a little bit of like a misterminology, like abuse of terminology. Like this data is the data going to GPU, but from a data scientist perspective, it's a combination of the actual data, the training data, and the model weights. So all those things are meshed together in the data input. Make sense? Okay, so that's a long answer to explain why sometimes you will select like 4 or 5 or whatever. Also, this can also jump around depending on how many GPU is available at this timeline, at this time spot, like whatever, it's like a Friday 7:30, right? That's how many there are. Make sense? Okay. So I'll just select one. So I'll just show you guys what it looks like. It's not going to be anything. What? Oh, hold on one sec. Okay. So once you create one, it's going to pop out a window like this. It's basically going to say, hey, we're trying to find the GPU, we're trying to stand up the pod, and then we're going to try to create an instance. And then it's going to give you like an instance. There are 2 ways to do this. If you're familiar with terminal, you can do it in the terminal. It's a Linux command. If you don't want to do it, there's a Jupyter Lab here, and then you can do it in Jupyter Lab. And then there's also like a remote access that give you like a SSH key. You can do that as well. But I don't expect you to go that crazy. You can just use a Jupyter Lab, and it will spin out Jupyter Lab, and then you can do everything in here. Make sense? And And then once this is turned on, I'll just show you guys one more thing. So this is kind of like Jupyter, like everyone's familiar with this, right? It's like Python notebook, right? You put your code in there or whatever. So this is how I will probably go about it. I will treat each project as its own container. And the way we're gonna do this is using UV. Anyone heard of UV? Um, what's the introduction? So forget about UV. Everyone heard of pip, right? Pip install. The pip install pandas, pip install whatever transformers, right? So the way that pip manages package is just slow, and UV is just faster in terms of package in terms of managing the package version from like one version to the other version. Like pip is just like when people say pip, people talking about this PYPI, blah blah blah. And then you can actually, this is actually open source, right? So anyone can create their own Python package. So like for example, this is mine probably, and I know. Um, like this one's mine. Like I created this, and then you can probably download this and then run the code yourself. And then this is kind of like a standardized way. But then the problem is if the provider of the software makes a new update, then in your project you have to make another update, right? And it's kind of like annoying. You have to do pip uninstall and then pip install and then do whatever that and then you have to resolve a dependency. Like what if I introduce like what if I introduce, this is 0.4.4, what if I introduce 0.4.5 that use another transformer that doesn't work with NumPy that you are currently having, right? Then you gotta uninstall the NumPy. And then what if that affects something else? And then you gotta uninstall that, right? So it kind of cascades to like a chain effect. And next thing you know, you're spending 5 hours install different packages. That's just not fun, right? So that's why we use UV. And UV does that all behind the scenes for you. And you don't have to install packages for 5 hours. So that's UV. And then the usage is actually very simple. So this is how I would go about it. Oh, sorry. So pip install UV to get things started. That's the only pip install you need to do. And then you just pip init some sort of project. Once you do it, you can go into the project. And then you can clean things up, and that's pretty much how you're going to do it. And everything's in this package. And then this package, you can do whatever you want. You can install whatever you want, and then it doesn't affect anything else. And then you can containerize it. This has its own container because once you install project, it has its own virtual environment, and then everything is in that own virtual environment. And just take my words for it, you're going to need it. Why? Because today's large language model, it's being updated a few times a year at least by the large companies like Google, Gemini, Meta. They update their packages a few times a year. So you're not gonna pip install keep up with their speed just completely manually by yourself. That's just not gonna happen. And then especially in a semester, and then especially during finals, just take my words for it. You're not gonna have time for that. So the best way is just to use UV, and then it manages all that for you. And then typically what I would do is I would start with a repo. I actually have a repo here for you guys to quickly get things started. Deep speed course. So now we're talking about deep speed. Deep speed is a package to handle distributed computing, right? So all that stuff that we just talked about, where did it go? So all the stuff that we're talking about here, like how do you go from one GPU to the other? Like like obviously you're not an electrical engineer. Like you don't write code in C++, right? So there's going to be some sort of wrapper that handle that transition for you, right? And that wrapper obviously is in Python, and that Python package is called deep speed. So very simple, you can clone this, and then there's all these stuff that's pretty much written for you. You just run the code. So that's how I would start it. And then based on all of this, the most easiest one you can probably get started is this one, because literally just a neural network with like a layer. Like I can show you guys this real fast. Like you go in here, it's just one layer. It's just one layer, and that's it. So you can obviously run that using 2 GPUs. It would just be lightning fast, but it's okay, you can do that. And then what it's doing is just a linear regression model. So it's a very simple model. You can run this out of the box. You generate some data, and then you just go ahead and train it. So in terms of training it, how do you use multiple GPU? In the normal PyTorch TensorFlow world, before multiple GPU, you just set up your device and you just run the gradient descent. Like gradient descent means you are setting up some sort of for loop, and then every step you are sending in a batch of data, and then you just update the gradient. The update gradient is just the backward propagation, right? That's it. Now, what's the difference of the code? The difference of the code is this thing here. And that's it. That's the only difference. So before you run your gradient descent, you tell the computer, you say, hey, look, before you do that, I want you to use deep speed. That's the only thing you need to know. And then this Python code calls this configuration file. And configuration file tells the computer the setup of this thing. So what do I mean by that? You go back to the repo, and then you go to this folder, and you go to JSON. So that's a setup. It basically say, hey, each batch is 32, and then the batch that goes on GPU is 32, and then gradient step is like it's getting updated every step, and then the optimizer is Atom. That's literally it. And then you can do a bit more like learning rate or whatever, if you wanna go that direction. And then there's like a floating point. Floating point is depending on like how like the byte size of the data and how finely you want the floating point to be. Typically 16 is fine. Make sense? So on a high level, if you don't understand any of that, that's totally fine. On a high level, actually also this stuff can also be generated from large language model. Like if you have no idea what I'm talking about, you just tell ChatGPT, you say, hey, I want to use deep speed training data, give me a config file. And ChatGPT will write that for you. So if you have no clue what's going on here, it's not the end of the world for the time being. But if you understand it, and obviously, you get paid more when you find a job. Because this stuff is like very few people know this, so this is highly important. Also, taking a step back, the only thing important here, literally on a high level, 10,000-foot view, high level, the only thing important here is to handle multiple, to throw a job on the instance and to run the job using multiple GPUs, you need to have a Python script and you need to have a configuration file. That's it. Versus in the old days, you just have a Python script, right? And that's kind of like the only difference. Make sense? And then I think I have instructions down here to show you how to install it. You start with, where do you start? I have to update this because it's kind of like convoluted. But basically how I will start is you use the UV add. Here, let me find a better one. This one is probably better written because more people using that for like obvious reason. This is how I will get started. So UV init the project, CD into the project, and then you just add all these packages. And then obviously all these packages, it's better that you know the version so that you can kind of better control where you are in the software development life cycle. And then once you add the packages, you create a config file, and then you create the token you can add in, and then you create a Python script, and then you just run it. And the way you run it is using UV run deep speed, and then you just indicate how many GPUs you're using, and then the name of the Python script. So that's pretty much it. Again, we're gonna come back to this in the future. There's gonna be a whole class dedicated to this. So if you're kind of like lost, it's no problem at all. Taking a step back, high level. This is a company called Rungpod, right? High level company called Rungpod. It provides you GPU. That's all you need to know. And then what's the package to do multiple GPU training? It's called deep speed. That's it. That's all you need to know for now. And that's a thing out there. And hopefully you guys will just have opportunity to do this. Let me take a pause. Any questions? Good. Okay.
Speed like SLI. NVIDIA has that SLI platform, right? You can connect two GPUs together.
I think how oh, you mean if DeepSpeed is connecting to NVIDIA GPU?
No, in general. To connect two GPUs together, you have to use an SLI platform.
Yeah.
And then you could use both of them in parallel. That kind of similar or?
It is similar. I have to look into more of what you said, but yeah, I'm gonna guess it's similar. Yeah. Yeah, any other question? Good. Okay. And then in the end, obviously shut it down, right? So I'll try this again. Stop. And once you stop, you terminate. And then just say terminate, and then you're good. Make sense? Otherwise, you just keep charging money. And obviously I use a little bit, right? So instead of 400, now it's like 399. Make sense? Any questions about this? Okay. Let me take a step back. I can probably now close all of this. Okay. Now the rest of the time, I'm gonna jump into code a little bit. Is this? Yeah, let me reconnect this. And then let me jump into code a little bit. Okay, so the rest of the time, I kind of want to just talk a little bit about the inference on like a large language model, and hopefully you guys get like a good understanding of what's going on. Let me start with installing the packages, and then I can keep talking. So Gradio, we talk about it. It's the front end app, right? Transformers, it's the transformer library from Hugging Face, help you build models, things like that. So out of the box, we just install them to make sure you're in a fresh environment and it's up to date. And then the goal that we're trying to do is previously, we talked about using Gradio to do image classification, right? So today we're gonna using Gradio to build like a small, not really a chatbot, but kind of more like a sentence, like a word generation bot to help you guys get an understanding of behind the scene exactly how does it work. So first things first, I'm gonna import the libraries. That's a library that you put it there. I'm going to explain this a bit more once I put the code here, but basically Torch, you need that. Transformer, you will need these two. These two, I'll explain more, but on a high level, you need a model, you need a tokenizer. And always, always, always remember they're two different things, right? They're two different things. They can go together and they should go together. It's not always the case that any tokenizer should go with any model. It doesn't work that way because the person that's training a model have their own tokenizer. Does that make sense? It's kind of like you have your own key to go to one door, and then you always use that one key. So that's what that feels like right now. And then also be aware that I'm on a CPU right now, and I want you guys kind of experience the speed, right? Because it's meant to be slow. The CPU is, if you go here, you can see that I'm on a CPU right now, right? It's not GPU, so it's meant to be slow. Okay, now that's done. The first thing I need to do is the tokenizer. So I will put the tokenizer here. Yes, grant access. So what's happening here is it will go on Hugging Face and download this model called GPT-2, right? It's written here, it's GPT-2. And these functions are kind of, you know, I don't want to say sneaky, but kind of like in their own way. It's written specifically for this model, right? You can't really use this to download like Llama 4, right? It's just gonna fail, right? And there's a special reason behind the scene. It's because the tokenizer, it's built for the model, and then the tokenizer converts the words into different tokens, into basically different pieces of numbers. And then you use those numbers as input to the model. So that's why tokenizer and model are two separate lines of code. In theory, you can probably do these two things in one line, but don't go crazy on that. This is tokenizer, and this third line is a model, right? And then to unpack this a little bit more, when you're loading the model, you always need to throw in the tokenizer. Make sense? So any questions? Okay, so before I continue, let me show you guys this website. So hopefully everyone can understand what I mean by tokenizer. So there's this website called taketokenizer.versal.app. Anyone seen this before? So it's basically an app. It's actually free, so it's just public app. You just take that URL and then you can run on your own computer. If you have no idea what I'm talking about, like what's tokenizer, like what does it do, right? Tokenizer basically take a sentence and turn a sentence into numbers. And these numbers are indexed that register what that word is, right? It's not the number that's coming out of the model. It's not the embedding layer number, right? It's just it's kind of like a dictionary. It's a way of indexing what the word is. Now I'm kind of like abusing the language here. Like when I say word, like I don't mean like word per word. Like I meant the word in the training data, right? So this is a little bit caveat because not everyone here has seen the training data, right? So training data kind of look like this. This is kind of like what the training data should look like this kind of stuff, like bracket, this vertical line, I am star or whatever. Like this is what a training data look like. And the reason it looks like that is because the large language model, it's guessing the next token. So literally it's guessing what this next number is. And when it's guessing next number, it's based on previous numbers, right? And when I say numbers, I'm talking about the index. And here the index is referring to the tokens. Okay, so now with that said, what's happening here is this website basically takes a sentence and then you can probably write whatever sentence you want. It kind of gives you like a preview of what the training data look like in the view of the developer, in the view of the model and the original source of training data, and then it breaks it apart in tokens. So on a high level, this is actually very interesting. On a high level, you think, hey, I'm typing a sentence that's like 1, 2, 3, 4, 5. I'm typing a sentence of 5 words, right? So you're thinking like, oh, maybe this is like 4 or 5 tokens. Well, no, it's not, right? It's 16 tokens. So I had a student last semester, hope to God doesn't happen again this semester. I have a student last semester saying they use ChatGPT for like not the UI, like he used a API, he had an API key and he's making API call to like a GPT-4 model. And he used it for like an hour and it cost him like hundreds of dollars. And he has no idea what's going on. So you happen to trigger the training data in a way that creates a lot of tokens. That's what's going on. And you don't see that. Why do you not see that? Well, you only see this. So in your head, you're like, oh, I'm on like 5 words, but no, in reality, it's 16 tokens. And this thing blows up really fast. So if you have no clue what you're doing, just go to this website, type things down here, and then you can kind of get an estimate of, how much token that costs you, right? Obviously, they charge you money on this, right? Because you're physically sending the data, however many kilobytes that thing is, right? How large this thing is, you're physically sending that data from your computer to the data center, like to one of these guys. Where's the picture? I forgot what the picture is. I'll just find the one. Like you're physically like taking some data from your computer and you're sending it here, and then you're getting something back, right? So that's why this could blow up real fast. And then that's also why when you scrape the document, you're just constantly making API calls. You're scraping a part of the PDF, and then you're saying, okay, this is my paragraph, give me a question. Oh, this is my paragraph, give me an answer. And that's how you create a question answer pair, right? So when you create a training data, a good habit is for every single chunk of paragraph, just go to this website and then kind of just get a gut feeling of like how many tokens you're just spending, right? So that's just one thing to mention before like someone go crazy with their with their budget. And then yeah, just something to be aware of. Any questions before I continue? Any questions about tokens? Okay. Now with that said, I can, where's my collab? It's probably this one, right? Okay. Now with that said, tokens there, models there. Now I can grab the rest of my code, which is so now I need a function that trying to guess what the next token is, right? So let me copy it here, and then I'll show you what it looks like. And this function is just, it should be pretty fast. Okay, so you need a function like this. So let's unpack this a little bit. So what's going on? So first of all, it's a Python function. So when you see def, that means you're defining a Python function, right? Okay, Python function takes some sort of input, and then this input just going wherever's going in here. And then you might ask, okay, what is this? What is this thing? Well, this is coming from whatever this model produce, right? So presumably it's like the last layer of some sort of neural network, right? Whatever that neural network there, that's the last layer of what that's producing. Okay, so you can take that. That's gonna sorry, I lied. Not the model. It's the input of the sentence. Sorry, I lied. It's the input of sentence. You send that into a tokenizer, and then the tokenizer is defined up here. It's this GPT-2 tokenizer. And then that becomes your input data. So this input data on line 3, after this line of code finish running, this input data is no longer a sentence anymore, right? So now it becomes a bunch of numbers. So you take a bunch of numbers. Now what you're doing is you're going through this with statement. Now, before you touch this, this is model.eval. Anyone know what that means? It is evaluation, but what is it like? What does it do? It's actually very unintuitive. That's why I asked this question. It's actually forcing the model to not do any additional thing. So that's what that's doing. No one knows. Like, how would you know that? This code actually resets. Sorry, not reset. It freezes things like dropout, things like random seeds, things like that in your training that typically you will need. If you run this code and you left nothing in here, it will just freezes all of that. So that when you are running the rest of the code, it's purely just inference. It's purely just making a prediction. It's not training. It's not the training setup. If you are doing training, then obviously this line of code will be a little bit different. Make sense? But anyhow, for now, that code will just tell the model saying, hey, we're only running inference. We're not changing any weights. So that's what that's doing. Now, with this gradient, you're not updating any gradient because you're not training the model. You just literally just guessing the next token. Make sense? So what does this do exactly? It's going through the neural network model. So this model it's defined up here. It's this guy here, GPT-2. And then this model is generating the next token. So let's go back to the picture a little bit. Sorry, not picture. Let's go back to the website here. Okay, so this token is here. Every single of these token points to one unique thing in the data. And this, you can kind of think about this as a corpus. There's only finite amount of human language, right? Human language is not infinite, right? There's finite amount of words, there's finite amount of tags that people create in their training data. Like when I say tags, I'm talking about this bracket, whatever that curly bracket is, that's a tag. It's a tag, and it means beginning of a sentence. It means end of a sentence. It means stop. It means, I don't know, whatever you want, like emotions. It means, you can even mean like classification. Like people, you can turn this around and then use a language model to force the output to be a classifier. So you can also do that, even though it's a language model, it's trying to guess the next token. So you can do all sorts of things, all because engineers can customize what the tags are. Make sense so far? Okay, so why am I telling you this? The tags, along with the words, form the corpus. The corpus is a dictionary, and the dictionary allows the model to try to guess the next word in the dictionary. So that's all there is. the last layer of a neural network model typically give you a probability, and the probability points you to the next most likely token, whatever that token is. So that's what this line of code is doing. Any question? Good. Okay. So we run that code, which we did, and then the last line that you need is the front end, right? I hope this works because we know that's the GPT, so it could be slow. Okay, so input output, and that's the front end. So let's unpack this a little bit. Function, that's backend, right? User interface, that's front end. The user interface doesn't do any magic. It literally just says, here's a text box. You can enter some text here. Here's a text box, and there's a sentence being printed. That's it, right? This line of code can be whatever you want. HTML, React, Node.js, all that fancy stuff, or whatever you want, right? If you don't know, then you can write it yourself. If you don't know, then ask ChatGPT, will write it for you. This stuff, it's the backend. Backend typically it's Python. Now, of course, depending on your preference, some people rewrite this in TypeScript or whatever, but that's a preference. For the sake of this class, when I say full stack, I'm referring to you can do both front end and back end, which means you understood what this is, right? You understood what this is. You might not remember these syntax. Like you might have to think about it and say, oh, I know the tokenizer function, but I forgot what that's called. Is it return tensor, return underscore tensor, return tensors, or return whatever, right? You might have forgot about the syntax. That's fine. No one cares. Like, that's what ChatGPT is for. ChatGPT will remind you what that line of code is, right? In the old days, obviously, hopefully you memorize yourself what the syntax is. If you don't know that syntax, obviously you have to read the API docs, right? The API docs will tell you, oh, tokenizer is a class object, and then there's an encode, which is a method or whatever. And then in that method, there's argument or whatever. Now, all that knowledge is in ChatGPT, right? That's what ChatGPT is built for. So if you forgot about all these stuff, like there's a width there, and there's like all these arguments, you forgot about some of these, that's what ChatGPT is for. Make sense? Okay, so once again, backend, front end. And then altogether, it's what we call full stack. Any questions? Okay. Now you understood what's going on. You understood front end, you understood back end. That's what the app look like, right? I agree, this is an ugly app. No one says this is beautiful, right? That could be an ugly app. That's totally fine. You can redecorate it using whatever you want, HTML, CSS. You can decorate however color you want, right? But that's another project, right? That's a user interface, user experience project. You also can't just say, I like black background, I don't like white background. That's kind of not your decision to make, right? That's the customer's decision to make. Customers have to use this, and customers have to tell you, oh, like that black is hurting my eyes or something, or that white color is hurting my eyes, right? That's not your call, right? Technically speaking, it's a customer's call. So, so when you're designing something like this, kind of just think in your head, like, what is your end goal? And then if your end goal is serving someone else, then obviously do your research who that person is and what color they like, right? Before you spend like 5 hours making this like green or something. Make sense? Any questions? Okay, so now we explain all that. Obviously, you can enter something here. It's gonna be a bad model, just so you guys know. Tell me a joke. It's probably gonna say something that's like close to nonsense. And also we talk about this, it's gonna be slow, right? Because I'm on a CPU, and that's how slow it gets. I'm not even sure this is working or not. Is it working? Oh, it didn't even work, huh? Say, hello, tell me a joke. Really? It didn't even produce anything. That's weird. Or what is 1 + 1? That's weird. Let me see if I can fix it. I'm gonna try to put it together and see if it works. If it doesn't, then I'll have to fix it because it's supposed to give you something. It's not supposed to give you. Is it returning? Oh, you're right. I forgot about it. Okay, you're right. You're right. You're right. Absolutely, you're right. I forgot a line of code. Yes. Good call, by the way. There's no return. Good call. There we go. Okay. Now I can probably rerun this. Good call, by the way. That's exactly what it is. Okay. Tell me a joke. Yeah. So I just say thank you to everybody. I mean, I don't know if that's a joke or not. Maybe you guys find that funny. I personally don't find this very funny, but you guys get the idea, right? It's trying to just guess the next word, disregard like if it's nonsense or whatever it is. And it's not meant to be a good model. It's not meant to be fast, right? So I'm showing you guys something that's not supposed to work very well. Make sense? Any questions? Okay. One last thing is probably just take the code and put on Hugging Face, and then you have like a live app. And then you have your first mini version of like a small not really a chatbot, but more like a question answer engine sort of thing. Okay. We're pretty much at a time. We can probably stop here. Like I said in the beginning, I only do 2 hours. Don't go crazy. So yeah, you guys are dismissed. I'll see you guys next Friday. I'm gonna leave a link in the announcement for the form. Just please fill it out to the best of your ability. And then just speak from your heart. Always read those comments. Yeah. Yeah. Yes, please. And yeah, I'll see you guys next Friday.